Okay. Now let me try it again. Okay, we're going to see if this works. So last time, this is just kind of what we talked a little bit about. You'll remember that we talked about the different scales, the mean, median, mode. I'm just kind of zapping through this because we kind of already talked about it, and I think we answered any or didn't have any questions on that. But really, where we kind of want to start is with the normal curve. Okay, the normal curve is it's also called the bell curve. And I will put this, I didn't even think about it. I don't know why I didn't think about putting these on Blackboard, but I will so that you have them. So I apologize about that, but we'll get it done. The normal curve, also called the bell curve, there's been a lot of different things out over the last 120 years about the bell curve. There's some famous books that have been written, especially in like the early part of the 20th century, talking about intelligence and the bell curve. You know, there's still, every now and then you'll run across a teacher that says, you know, in this class we're going to follow the bell curve, and so, you know, plan on 68% of you getting a C. And I mean, you know, there's still that thought process out there. And the bell curve, there is a lot of credence and a lot of value to the normal curve, if we're talking about the right population size. You know, trying to come up with or adhere to a bell curve at a population size this big, of 10 or less, is really impossible and not feasible. You know, when you start talking about a normal curve, you're going to see this. You're going to see a normal curve in things like, and I keep kind of using that because it's something we started doing this year, but map test scores. When you got 3 million map test scores across the United States, you're going to see them in a bell curve. You just will, because there's enough samples there. The sample size is large enough that it makes sense. In the overall population, you see a normal curve in everything from, honestly, intelligence to height, right? There's an average height in America. You see, and depending on what population you define, the normal curve, the values in the normal curve may change. The average person in the United States, height-wise, average male, might be 6 foot, let's say. I'm not even sure what it is, 5'11", 6 foot. In China or an Asian country, that may be small, may be shorter. I mean, so it really is dependent upon what population you're studying as well, or you're looking at. But the normal curve is there. It is valid. There is some value to it, and we'll kind of talk about that as we go through. You'll notice in the reading, and I'm not going to spend a whole lot of time on it, in the reading it talks a little bit about peakedness. Really, that's kind of where the peak of the normal curve is at. You'll notice there on A, the peak is a little flatter than, say, B, or where the peak would be on A. Basically, what all that's showing you is that the scores are more evenly distributed here along the vertical axis than here. Okay? I mean, and the peak, remember, the peak is the score in the, so here, in a normal curve, that peak is the mean, median, and mode. Right? Remember that from, I think, the first or second night? I think second night we met. Okay, so in a normal curve, it's going to be, all three of those numbers are going to be the same. Okay, something I want you to take a look here. We're going to come back to this slide. This has a lot of information on it. Okay, this particular slide. Right now, I want you to think about, okay, we've got the normal curve here. You'll notice that within the normal curve, we have the standard deviations. 1, 2, 3, and 4 on one side, positive, and in the negative. Okay, so basically what this is this is the average. Remember we talked about the mean being the average. And what we're saying is 68, this is standard. Now, you talk about things that I need to remember. You need to remember these percentages. Okay, you should know that 68% of all scores in the normal curve are going to fall between one standard deviation above and below the mean. That is something that you'll come back to over and over again. So that's something you need to need to know. Okay?
Repeat that one more time.
That 68%, 34.13 and 34.13. So 68, the majority of scores fall within one standard deviation on either side of the mean. Now, 95% are going to fall within two standard deviations. Okay, so 95% of whatever we're talking about. Let's say we're talking about height in the the American population. 95%, if the average is, let's say for males is 6 foot, okay, then 68% of the population are going to fall in a height that is one standard deviation above or below. Now, in this particular example, we need to know what is the standard deviation in height. And I'll bet if we Googled it, there's one out there. But let's say that the standard deviation in height is 3 inches. Let's say standard deviation in height of American males is 3 inches. The average is 6 foot. The standard deviation is 3 inches. So what that tells us is 68% of the population of American males is going to be somewhere between 5'9" and 6'3".
Okay.
So the majority of the population. Now, another way to think about that is that from a statistical standpoint, 5'10", really 5'9", is not that much different than 6'3", from a statistical standpoint. Now, you ask somebody who's 5'9" if there's a difference between 5'9" and 6'3", and they're going to say yes, right? But from a statistical standpoint, it's within one standard deviation above or below the mean. So if I'm 6'3" to 6'6", I'm in this 13.5% here. I am within 2 standard deviations above the mean. Or 5'6". You see that? So 98% of the adult male population in this country is going to be somewhere between 5'6" and 6'6", if the average is 6 foot and the standard deviation is 3 inches. Does that make sense?
Thank you for the example.
So it doesn't matter what the example is, whether it's height, whether it's intelligence, whether it's test scores, whether it's reading ability, okay? It's all going to be assuming that it falls as a normal curve. It's going to look something like that as far as percentages wise. Now, the smaller the population, the less like that it's going to look. Right? Now, we can still apply the standard deviation, the 1 and 2 and 3 standard deviations, and have an idea of where that student is scoring or where that reading level is. We can still have that. We just have to understand that it's not going to be a normal curve if the population size is 30. Okay, so we're gonna kind of come back to some of this now. This, keep in mind, this never hits the x-axis. Okay, the normal curve never touches the x-axis. There's not a point along there where the x-axis and it crosses or touches. Now, that's in theory, right? And very rarely do you get out here to 4 and 5, quite honestly, standard deviations. Now, can you? Yes, you can. You can have somebody who's scoring way off the charts one direction or the other. I mean, it is a possibility, but very rarely does it happen. And you notice that in only 0.13% of the time will you get beyond 3 standard deviations. Okay, so 99.74% of the time, 99.74% of the time, if I've done my math right, will you be within 3 standard deviations of whatever the mean is. That's the grand majority of time. And that will be somewhat useful when we come down here and talk about t-scores. Okay? But this is a slide that can be pretty valuable to you from the standpoint of there's a lot of information on there, a lot of ways to break down the normal curve. Right now, you should have an idea of the standard deviation and what that looks like and why that's on there. And we're getting ready to talk about the z-score and why that's on there. Okay? Are we okay to move on, to move forward? I heard a groan.
No, you saw a light bulb go on. When I was looking at the z-scores, those are just standard deviations.
Okay. Characteristic of a curve, it's symmetrical around the vertical axes, meaning, we cut it down here, it's going to be the same on both sides. Scores clustered around the center, so you'll notice, here it's symmetrical, scores clustered around the center, so most, 68% of the scores are around the middle. Mean, median, and mode all have the same value, so right up here, that's the peak of that particular curve. No boundaries on either side. We kind of talked about that. Remembering small samples don't look like the normal curve. We talked about that. And the larger sample size, the more it looks like that. So we talked a little bit about that.
Wouldn't have the same mean, median, and mode if it's not a curve. If you're working on data and it's different, it's not going to fall. I mean, that's an indicator. It's not going to fall. Right?
Well, no, not necessarily. Looking at it like here, this curve would not have the mean, median, and mode, because your mode is going to be here. This is a multi-peaked curve. One value is going to be there, and your mean is probably going to be somewhere in here as well. So that would not be a normal curve. Okay, so let's talk about the z-score real quick. A z-score represents the number of standard deviations that a score is either below above or below the mean. So if we come back to here, you'll notice, as Bobby did, the z-scores correspond with the standard deviation. Okay? So the z-score is designed, remember, the standard deviation tells us something about the overall population of scores. Okay? The standard deviation tells us something about the overall population of scores. The z-score is designed to give us an idea of where within that band of scores that particular score is located. So the z-score is designed to tell us where an individual score is located within that curve. The z-score is the most common standardized score, and we'll talk about all of those scores here are types of standardized scores. All of these are standardized scores of some kind or another. The z-score is the one that's going to most commonly show up, either in the reading or in what you choose to do with it. And in fact, if I'm throwing in my 2 cents, I think it's the most easy one to work with because it really just kind of mirrors the standard deviation.
So I'm sorry to be so
That's
dense on this. So the standard deviation is just describing the units, I mean the intervals kind of, but the z-score is telling you where it is. That's the difference?
The standard deviation tells you tells you really distance within from the mean.
From the mean. Okay, so that's the purpose. It's describing.
It's describing the overall scores and giving you distance from the mean so that you can make some determinations on, is it really what I call statistically different. We aren't talking about statistical significance yet. We're just talking about statistically different. And there is a difference there between statistically different and statistically significant. Okay, now you'll notice there that the z-score is the raw score minus the mean divided by the standard deviation. So what that means to you is you have to be able to figure the z-score for each individual score, you have to know what the average of the population is, and you have to know what the standard deviation is. Okay, so in our instance, if I was going to figure a z-score for the height, let's say, of somebody who is 5'8", I'd have to, now what I'd have to do is I'd probably have to put that, in some kind of table that I could work with it. You know, we're not subtracting 5'8" from 6 foot and doing it that way, right? I'd probably put it more in like a group frequency table or something like that. But the idea is I take my raw score, so my 5'8", I'm going to subtract my 6 foot, and that gives me, you know, a difference, in this case, of a negative number. That's going to be important for a minute. We're going to divide by the standard deviation, 3, if that's what it is. It's going to give us a negative z-score. Now, let's talk about what's important about that. What is a negative z-score? What's the first thing that's going to tell you?
The raw score.
That's right. It's below the mean. So right now, I know, just based off the sign, where that score falls. It falls underneath the mean. Right? Real simple. So it tells me direction, but above or below the mean. Now, the size of the z-score will tell me where on the normal curve it falls. So if the z-score is, let's say, negative 0.8, then I know that it's going to fall right here, give or take. Right? That's the z-score. It's a negative 0.8. So I know it falls on this side, and it falls right about there. So I have a conceptual idea of where it falls. I have a conceptual idea of how close is it to one standard deviation, below or above. Because remember what we tell you, kind of one standard deviation is, well, it's like a magic line, isn't it? Once I get below, or I get, below one standard deviation, meaning 1.1 standard deviation, now I'm significantly different than the average. Okay, so it gives me that idea.
Okay, so when you see raw score on our Excel sheet that we did X minus mean. Is X and raw score something?
No, X is the
It's
same
X.
thing as raw score.
Got it.
That's a great question.
Okay.
Great question. X and raw score are the same thing. Now, to find the z-score, all I'm going to do now is I'm going to take that answer and divide by the standard deviation.
Right. But we would have had to have gone through the whole process that we did in order to find.
Right. That's,
So we already have the column of X minus the mean. We already have that whole column.
and you've
there.
already found the standard deviation.
And we've already found the standard deviation. So
Now all you have to do is divide one by the other.
The z-score would just be the equals and then that column number, whatever, if it was F13 divided by and then whatever our standard deviation, that would be the formula to find it.
Right.
Okay.
And you just described our activity for the evening.
Oh, there you go.
So we're, all we have to do is just add another column for z-score
But it's not even a
and
column.
put in a formula.
Yeah.
Okay.
And keep in mind, I'm less interested in you being able to do that and more interested in you understanding conceptually what we're talking about here. Right? Let's say, okay, let's do this. Let's say that the z-score, let's say the z-score that I get is -2. Okay? What does that tell me about how, let's say it's on a test. What does that tell me about how I did on that test? Compared to, let's do this, compared to everybody else who took the test.
You were significantly
You-
lower.
Okay,
you were
I
a
was
lot lower
significantly-
than the average.
You were a lot lower than the average because you were below the ones.
And in fact, I only scored higher than 2.27%. So if there's 100 people who took that test, I only did better than 2 other people. Okay? So you can kind of think about it in those terms as well. If you know, even if you don't know how many people took the exam, you could say, if I got a z-score of 0, then I did better than 50% of the population who took that exam. If I got a z-score of -2, I did better than 2% of the population who took the exam. Same thing here. If I get a z-score of +2, then only 2% of the population did better than I did. You see, so it starts giving you some understanding or some idea of how people did or how you did compared to everybody else. That's the key. That's the key to understanding the standardized scores. Okay? The standardized scores are designed to allow you to compare 2 different examples across populations. Okay? Let me give you let me give you a for example that I can't remember if it's in your book or another book I was looking at. Let's say that you have a friend who's in a different stats course. Okay? And on the midterm, we're going to have a midterm coming up because I understand we're supposed to have one. And let's say that the total points possible on our midterm is 50. Let's say your score is 45 with a standard deviation of, I don't know, let's say 7. Okay? Now your friend is in a stats course and they take a midterm exam and their total points possible, because me and I don't talk to the other stats person, their total points possible is 100 points. Let's say his score is a 70 and the standard deviation on that exam was 12. Who did better?
Down the left.
Why?
Better.
Because he's within one standard deviation of the total. And the other guy's outside that. His Z score is going to be less than one. His is going to be between 1 and 2. Actually, it'd be almost 3.
I don't know how you. I don't know. I have no idea how you got there.
Okay, that's where the Z-score comes in. Okay, so we could figure a Z-score for each one of these, and the higher the Z-score, then that. So what we're doing is we're comparing, because this is like it's comparing apples and oranges. It's kind of like comparing. We want to compare apples to apples, and right now we're comparing apples to oranges. We're comparing this
Yeah, well,
to
so
that.
Not enough
You didn't give us a mean on either one of them. We
Well,
couldn't
that,
calculate
see, that's
either.
why I have a raw
Oh, why did
score.
you say that?
I have a raw score, but I don't have a mean, and
Why
so I
did you
have
say
no
that?
idea. Because I thought I was supposed to get it from somewhere.
If we
You
stare at
should've
you
said
long
that.
enough, you'll give us the answer.
Let's say, okay, so we're going to say the mean here was 40.
So now we can.
And we're going to say, you should have said that, because I didn't realize I didn't put one up there. I apologize. We're going to say the mean over here is, let's just say it's 70.
Okay, now I can calculate something. So,
You guys are supposed to tell me, but I don't put all the answers up there.
Well, this guy over here still scored. He still got a positive Z score.
Yeah.
So he did better.
divided by the standard deviation. So his is
It's about
39.2.
Points. Huh?
Did I do it wrong?
I don't know. What'd you say? 39? I was
Well-
thinking about 35.
If it's
Yeah.
the raw score is 45, and you subtract the mean, right?
Which is
That's 5
which
divided
is-
by 7.
40, and then
which
you
is
divide.
0.35. No, it's not.
It's 39.28 or
Okay. Yeah.
whatever.
0.3938. 5 divided by 7.
That's
5 divided by 7
I got
cannot be
0.7.
39.
7142.
5 divided by 7
Oh, I
Five
put
sevens.
in the wrong.
is less than 1.
I put in the average. Sorry. Okay.
Well, I saw right away that one was 0. But this guy's still a positive Z score, so he's scoring above average.
So he did better.
He did better. Right.
Well, I can see
But
that
the only
because-
reason we can compare those, okay, the only reason we can compare those is because they are, what they're doing is similar. What I mean by that is they're both in a stats class. Now, let's say that this was beginning statistics, and that was advanced statistics. It's no longer fruit, if you will. It's now a fruit and a vegetable. They are different, and I can't, with any validity, say that this guy did better.
Because it's different content.
That's
so
right. It's different. That's right.
But within his class, he did better. You
Did
can't
better
say
than who?
than that guy did in his class. Can't you still say that?
No, you can't.
You still can't say
You
that.
can't, because they're two different now.
Okay. I thought with the Z-score you could. That was the great equalizer.
Well, that would be like saying this guy has a Z-score of point whatever it is in height, and this guy has a Z-score of 0 in intelligence.
Okay.
You can't compare those two because they're not the same thing anymore. You can't say he is taller or he is not as tall as this guy when this isn't
But
height. It's
what I said
intelligence.
was within their groups.
Well,
This guy did better because he's got a positive
better than
Z-score.
who though?
Well, better than most people in his class. I wouldn't say most, some. Better than some in his class.
This tells you that
Because he's less than one, so it's.
that he did better than probably. No, I'm going to guess here a minute. Yes, he's on this side, so he did better than everybody else on that side of the.
Yeah,
That's
he did a
not
little
where
better
he's
than
at.
an average guy in his class.
But he wasn't
But he's,
statistically different from the average.
and he's not significantly different because he's less than one.
Well, we haven't even begun to talk about correlation yet. You're just
Okay.
when you said significant, now you're talking correlation. That's completely different ball of wax.
Oh.
He is not significantly different than the mean is about all we can say right now. And we can say, you're
Well, that's
right,
what I said.
that
That's what I thought I said.
that he did better than
He
58%,
did better than 50-50.
yeah, than everybody else in his class. But it doesn't anymore tell us if this is advanced statistics and this is basic statistics. It doesn't now tell us anything about how he did compared to these students in this class. Okay? So another way you could look at it, if I were going to apply it to a high school, okay, as long as if this is a test in Mr. Smith's class over American history, and this is a test in Mrs. Jones' class in American history, and they're both pre-AP American history, okay, we're good.
But are
Over the
you
same
really?
content.
Because you have the difference of instruction and instructors and assignments and comparing, just from my own experience, comparing even that, there's a kid who could make an A in Mr. Smith's class and they have a C in Mrs. Jones's class because of the different ways they have instruction, they count, they grade, and so supposedly we should be able to compare them, but really you can't.
What you're comparing is you're comparing how well this student did in this class to how well this student did in this class. Now, what you can do, because you also have the picture of the overall class, if we assume that if this guy, let's say this guy is easier
Mhm.
than this lady,
Mhm.
okay, then we have to assume that he's not easier on one person in the class, but he's easier on the entire population.
So we're just comparing them based upon their own classes, not comparing them.
Both.
One did better than the other.
Both. What we're doing is we're saying this person is in a particular position in their class.
Correct.
And this person is in a particular position in this class.
And I got that, but then I thought you were bringing them together
We
to
are.
say, okay,
We are.
but that's where I think that you can't do that in everything unless you know it's
Because here's what I'm doing. I'm assuming that if the scores are lower here, that so too is the average, and so too is the standard deviation. If it's all lower, then
okay.
you see what I'm saying?
Yeah, I do.
Now, if you're telling me that the scores here are lower and the average and the standard deviations are relatively equal, they don't have to be the same to be equal, right? They don't have to be the same
Right. They
to
have
be
to be the
equal.
same number to be equal.
Right. I mean, that's the classic education piece that, you know, I can have eyeglasses and you can't. We're both accessing, we have equality going on, but I have something different than you. So we don't have to be the same to be equal. What we're saying is that the relative position of this person within this class can be compared to the relative position of this person in this class because we have standardized them with the z-score
Okay.
or the t-score. Standardizing them by definition now means we can compare them. I can't out and out compare raw scores. I agree with that. If you have a C and I have an A, we can't out and out compare those two. But because of your C and the relative position it holds within your
My
class,
own class. It can tell me. Okay.
right? Because that's really what we're measuring is we're comparing the relative position of your score to the relative position of my score.
But that doesn't make an equality statement. It just is a position statement.
Yes, but in making a positional statement, I can then make a statement of did you or I do better in the class? Let me do it something else. No matter what your grade is, your z-score has got to fall somewhere along here. And no matter what my grade is, my z-score has to fall somewhere along here. And if your z-score falls here and my z-score falls here, because it's a standard score, you by definition have done better than I did. Even if this equates to a C, a 72%. Does that make sense?
It does. I just
You're just
gotta-
wrapping your head around it.
I have to take out the factor of the actual raw score. That's what I'm comparing
That's-
instead of
Yes.
the z-score.
That's why we're dividing it by the standard deviation, is we're taking that whole piece out of it. Okay, we talked about that. Okay, so let's talk about the next one. The t-score, okay? The t-score is just another type of standardized score. The beauty about the t-score is it is nearly always positive. So for some,
Nearly all.
Nearly always, because remember what I tell you. That's cool. That normal curve never touches, never comes in contact with the x-axis. It is nearly impossible, but not impossible. It is nearly impossible to be 5 standard deviations below the mean. If you are more than 5 standard deviations below the mean, the t-score could be a negative number. Okay? That's what you're doing here. Your z-score multiplied by 10 to turn it into a base 10 number. I mean, a number that's, you know, either 10 or 8 or whatever. I mean, it could. And then you're going to add 50. By adding 50, unless the score is 5 standard deviations below the mean or more, you're going to have a positive number. Let's do this. Let's say the z-score is 4. Let's say it's at 4 standard deviations below, so negative 4. Well, negative 4 times 10 is negative 40, plus 50, that gives you a positive t-score of 10. Only when it gets to be a z-score of 5.01 below will you now have a negative number. And that is nearly impossible. Nearly meaning almost never will it happen possible. Okay? So if we go back to here, t-score, you can see if the z-score is 0, 0 times 10 is 0, plus 50 is 50. If the z-score is negative 3, negative 3 times 10 is negative 30, plus 50 is 20. Okay? Now, you won't see this one as often as you'll see the z-score, but you will see this one. Now, do not get the t-score mixed up with the t-test. Okay?
Little t-test.
There is a test, a statistical test that we'll brush up against in, I don't know, 3-4 weeks probably, called the t-test. It is not how to figure a t-score. So don't get confused about that. All right?
So what's the significance of the t-score? Why do we?
It's people use it because they don't want to mess with negative numbers.
Okay.
If you don't want to mess with a negative, if you don't like negative numbers, if you just can't wrap your mind around a negative z-score, then convert it to a t-score and it'll always be positive. Okay, I said that. Now, you will not see this one very often. The reason I have it on there is when you do see it, it's in educational literature.
I was going to say, yeah, we do. I know that one. I don't know T and Z, but I know NCE.
It was developed specifically by and for the U.S. Department of Education so that they could use it. And there are specific reasons for this 21.063 and why that number is what it is. If you want to know it, you can look it up, but honestly, I don't think it's all that important. And, you know, it's a constant. I mean, that's how you find the normal curve equivalency. Okay? And it's honestly, I mean, just when I looked over it again, I thought, boy, that's going to be confusing, and so I'm not really even going to talk about it. But you can look up in, NCE, normal curve equivalent, and it'll tell you it's like a 5-step process on how statisticians came to this number of 21.063. Okay, it's kind of like a mathematical proof, quite honestly.
So what do they use it for?
What do you see it in, Susan?
Well, in test scores, you're always looking at the NCE and the data. I mean, I mean, I don't know that I don't know.
Pay attention to.
You can actually have negative NCEs. So you got kids that are negative.
Well, I just know all the test scores that come back.
It'd be a really small population because that's more than 3 standard deviations away, but still.
And I never understood what any of it was.
Every now
I
and
just
then-
looked at the graph and the picture and it
every
was
now and then
given.
Ashley Daniels say,
Honestly, I don't think that they do. What I do know about it is it doesn't. It's a range of 1 to 99, and so anything below about 2.25 standard deviations is just considered 1. It's kind of like an ACT score. You know, you get an 11 on an ACT for writing your name down. So, and it takes several right answers to get a 12. So anything between there and there is an 11. Well, it's the same kind of concept here. That anything between, like I said, about 2.25 and below is a 1, and anything above is a 99. And if I remember right, oh yeah, there we go. I did read that. The NCE, the 21.063, is there to ensure, I do remember that the percentile rank of a 1 is an NCE score of a 1. And the percentile rank of a 99 is an NCE of a 99.
So that's why they have the 21 point.
Yes, that's one of the, yes, that's part of it. And I believe it also has, it's also designed to have standard, the same, what do you call it? The same distance between each of the 10. So
So it's
between
an
1 and
interval.
10 is the same distance as 10 and 20, which is not in percentile rank. Okay, percentile rank, it just if you'll remember right, percentile rank is just you line up the scores from top to bottom and you say, you know, the 32nd score is what percentile rank? And you divide it, 32nd score divided by the total number of scores multiplied by 100 gives you what the percentile rank of that particular score is.
So the percentile rank tells you exactly you did better than X amount of kids
Yes.
or others. But the normal curve would tell you where you were to fall if there were a perfectly normal curve.
Mhm.
That would be the
Right.
So there could be a big difference. You could be in the 9th percentile, but yet in the 20 NCE, right?
Yes.
Okay.
Yes, you could.
Okay. The government wanted a nice curve, I guess.
They're not all that bright, the people that work with the government. So, no, I'm just kidding. I don't know.
And you will post this if you haven't?
Yeah, I will. I'll do it before I leave. I don't know why I didn't do it before. Okay. The last two that we'll kind of look at. There's one that you'll come across in some of the readings called a stanine. A stanine literally comes from the word standard 9. So what they've done is they've broken up the normal curve into 9 sections. Okay. Where the mean is 5, they've defined it. The mean is 5, and there is a standard deviation of 2 in a stanine. Okay? And so the way that looks is here. The mean is 5. And so if we were to break up the normal curve according to the stanines, remember that we said between 1 standard deviation above and below it was what percent?
68.
68%. Okay? Well, the stanine breaks it up differently. So just to have kind of a conceptual understanding, here's 1 standard deviation, 2, 3, and so on. So you'll notice 1 z-score or 1 standard deviation is about in the middle of that 12%. So you've got about 6% plus 17 to there. That would be that 68%. In a stanine, you're looking at 20% the average, slightly below average 17, slightly above average 17. So it's still standard as you move out. It's just, it's different. Okay, it's just another standardized score or way to report standardized scores.
Do we need to know those percentages too?
No. These are the only reason I'm showing you the standard, the Stay 9 and the grade equivalents NCE is so that you recognize them. The ones you really need to be aware of, number one is the Z-score, because that's the one you're going to most often use. And then if you really don't like the Z-score, you can do a T-score. But beyond that, I'm not going to necessarily expect you to know or produce on an exam what the others are, but I will expect you to recognize them in the literature. Okay? And then you all know what grade equivalents are, correct? Grade equivalents just, it'll give you a reading score, for instance, that says, in fourth grade, a fourth grader might be reading at 4.6. Grade 4, 6 month.
What months do they go up
I don't know. Do you know, Susan?
It start. I was thinking it starts 9 months. Like there's 9 months of school and then to
to? Just goes up to 9.
in STAR. I mean, I know AR's
Yeah.
AR and STAR scores, but I don't know about others.
That's why I was curious.
Success maker makeup.
Okay, so we come back. That's why I say I really like this slide. So this may be one you want to print off and just kind of keep somewhere because it gives you kind of all that all in one giant fell swoop. Questions about standardized scores? Okay.
In,
All right.
in a future class, are we going to get to effect sizes?
Yes.
Okay.
When we start talking about correlations and regressions.
Okay. Okay.
That's actually, see, I actually think regressions are the fun part of doing this particular piece.
That's an interesting adjective.
See, I was thinking it wasn't going to do it, messed up. Okay, well, it doesn't look like I did record it. I thought it was going to, but it did. Camtasia didn't work. It worked at home, but I think what happened was when I plugged it into here, it went away.
I should have recorded on my phone.
Huh. All right. Well, that's great. All right. So now what I did do, okay, so let's talk about this. I saved this in the assignment section. It is going on 8:10. Okay. So you have roughly, we have 20 minutes here. I am going to, we're going to talk a little bit about this. I'll answer any questions. I've got the computers out here saved, so if you want to go out there, you can. If you want to just go home and do it there, you can, and you know, send it to me however you want to do that. Here's what I want to do. Okay? I have these students. I think it's 189 of them, maybe 190. They've all been taking the MAP assessment during this last window. This is their reading score. Now, I'm just going to tell you how I generated this. Okay? This is how I generate random numbers. There is a way in Excel that if you want, I'm going to do it over here, equals random between, okay? And I wanted my bottom number to be, I don't know, 215. And I want my top number to be, I think I set it at 265. And it gives me a random number. Now, I can copy that down. Watch what happens to that random number.
Why did that one change?
It just gives you a bunch of random numbers.
Every time you do something to it, it gives you another random number.
Gives you a new set.
Depends on what you do with it.
So-
Like, let's say I might just do something with those two.
I'm sure they're really good.
So anytime you click on it, it makes it random again.
Yeah.
And there's no rhyme or reason to the spacing between it or why it picked it. It's just totally random. Okay.
That's why, yeah, it's a random number generator.
Okay.
Now, all you have to do is tell it, what do you want from what number to what number? And then it does it. So what I did was I did that. Now, if I want those to stop randomizing, what I do is I choose them all and I copy. Okay? Now, watch what happens. If all I do is just paste them in there, I didn't get the same numbers. See that? But if I paste the values, I get the same set of numbers. No, I did. These changed again. Okay? So what I did, why would I do that? Because, look, I don't want these changing. Once I set these, I don't want them changing. Because if I allow them to change, your data will not be any good.
So what'd you do? Did you create a list over here and then copied it over there?
And then I paste specialed and only
Paste
pasted the
special, pasted
values.
the values. Okay.
And then I deleted everything else. Okay, so now I show you that just because in the stuff you guys have put on, most of you seem to say I don't work a lot with Excel and I'm trying to teach you little things as we go along.
You just typed in random.
Rand between. But if you start typing equals RAN, it will bring up all your options.
Mine doesn't do that. Even if I start pressing random.
Okay, let's do it a different way. I want to insert a function. What function, it asked me, would you like to insert? Well, it
Oh,
knows
you're
that
doing T-squared, I'm sorry.
it knows that I have done rand between before, so it gives me that option. Those are the ones I've done more often than not. Count sum, square root, mode, average, median, standard deviation, standardize, which will give you the z-score, and random between. Okay?
Standardized gives you the Z-score.
Mm-hmm.
What do you have to do? Select the data set that you want to look at.
I'll show you.
And then do it.
Okay, so you all remember how to find the mean, correct?
Mm-hmm.
On Excel?
I'd probably have to go back to my old page.
Equals average. And then tell it what numbers you want to average. In this case, I think it's B2 through B190.
290, I think.
Or 290, yeah. Now, here's what I would tell you.
Format your cells.
Well, at some point, but remember to format the cells. Now, if I were using straight significant figures, then I would do it to 3. In this case, it would be 0 because I only want these 3 significant figures over here, the 2, 3, 4. So the hundreds, the ones, and the tens. I always like myself 2 decimals after the 2 digits after the decimal because I just do. So you kind of whichever one you want to do. I mean, whatever your personal preference is, but this is really unrealistic. You're not going to carry anything out 6 places after the decimal point. So if you want, and you want to format those cells, this is where format cells. number. I always do the 2 because I like 2. 2's a nice round number. Median.
It should be 291 though.
Yeah,
Because I got a different name. There's 291.
sorry.
That's easy enough to fix. I'll go back over here. I put it in the assignment section.
Oh,
You did?
did you say that?
Yeah.
Totally. I'm sorry. I totally
That's
missed
okay.
that.
And how many decimals did you tell us we should do 2?
You do. I do 2 because I like 2.
Okay.
2's a nice even number.
I still got 2.
Oh, mine's still set on 1 and I don't know how to reset it back to 2.
So now, how do I find the median?
You put equal median.
I just type it in.
Really?
It gives it to me. What numbers? Well, the same number. B2 colon B2, what do we say, 91? There's my median,
Get out of town.
233. What do I have to do to find my range?
RNG.
You'd think, wouldn't
It
you?
doesn't work.
You'd think. So what I would do, because I don't want to mess up my, I like it being in student 1 through, I'm going to come over here and I'm going to copy. Now you all realize if we go through all this stuff, I'm going to send you a whole nother data set and you're going to be doing it so that you get practice with it.
Wow, still have
I'm going to copy it. And I'm going to put it over here just because that's where I want it. And what I'm going to do is I'm going to sort that. There's my sorting button, arrange data. It says Z through A. I'm going to sort that ascending. I'm going to find the range. So I'm going to equals B291 because that's where I know the largest one is. And I'm going to subtract B, oh not B, K, K291 and K1. Oop, it's going to be 290 by the way. It's going to be K290, I can tell already.
Why is it K29?
Because when I moved up
Oh, you
one
moved
cell.
up
So the range is 70. You see how I found that?
one. All right, hang on.
Here's
Let me write that down
Can you
again.
say that one?
Range.
What you said?
Okay, so what I did
Copy.
was I pulled the only way to figure range is to resort this whole number line, resort this whole column, and then subtract the top score from the bottom score. That's the only way to find range in Excel. And so rather than mess up, once I get a data set, now this is something you may want to do, okay? I don't know how you do it, but the way I do it is if I have a data set, then typically I will start making sheets down here. And my original data set will be in sheet 1. And if I'm going to manipulate my data in any way, I make sheet 2. And I copy and paste my entire data set into sheet 2 and I manipulate only sheet 2. That's the way I do it, typically. Because this isn't data that I really care
That
about,
way, when you accidentally hit the delete button,
I can go back to my original data set. Okay? And so I copied and pasted this. I pasted it over here. I resorted it from smallest to largest. I subtracted the largest number from the bottom number, got 70, and so I put 70 in the range because that's what the range is. I don't remember if it's going to find variance.
Sorted from smallest to largest.
Yeah.
Okay, and then subtract.
Thank you.
yeah. Which one of those variances is the one we use?
Yeah, that's
Okay, what do you think variance P means? Based on what you already know, what word?
Percentile.
Population.
Population. So what's S?
Sample.
Sample. So which one am I going to use? The question is this a population or is this a sample of a
If we're going to use the
population?
entire data set, it's a population.
We can define it as a population. Okay? We can say we're only interested in these 290 kids. All right? Now, if what you're saying is this is a sample of 290 out of a population of, I'm going to use Rogers and say there's 1,200 eighth graders and this is a sample of 280 of them or 290 of them, then I would use variation for sample. But in this case, I'm going to use population.
Well, how would you put in the variation of sample? Do you have to tell it what your overall population is?
No, because the only difference between population and sample, remember, is it's either going to divide by n if it's a population, or it's going to divide by n minus 1 if it's a sample. That's the only difference.
And it's not really that big a difference when you have a large, well,
Right.
you have 290 numbers, it's not that big a difference.
Yeah, you're dividing by 290 or 289.
Yeah.
Now, you're dividing by 10 or you're dividing by 9. That can make a difference.
For me, var.p or var.s doesn't show up as a choice. So is that something I need to type in? I just
Okay.
did var.
Okay, so try this. Go up here where it says insert
Okay.
function. Now, does it give you that box for formula builder?
Do you know what? Mine didn't look like that. Where you've got insert. Mine just opens a tab. There's not a drop down menu. So what did I do? Because I was going to try to figure it with the different ones here.
between.
Yeah, I was going to try to do
Go over to data. I bet yours is in data.
So I just did VAR.
Bless you.
It's important. You're so important.
If he just gives me everything at once, bless you, learn it. I cannot learn it that way.
We need to go take some medicine.
Yeah.
I'm telling you. Susan, did you find it?
Yes.
Okay.
Thank you.
Come on, dude. You got it, Bob.
Bless you.
After I got the flu, everybody in my house got cold. So I kept thinking people were getting the flu, but it was awful.
Bless you.
Okay, so
I can't even get the time to take it.
It's driving me crazy because I can't do it.
I don't know why it won't open.
I don't either.
Yours won't either?
I have no idea. My page won't open. I can't get to.
you can't get to the Excel.
I bet you have a more updated Excel than this.
I
Mine
can't
works
get.
fine.
No, I just can't get. I got to Blackboard, but it kicked me off. I
Well,
can't.
I was having trouble. I couldn't even get into. I was trying to look at the literature review thing. I couldn't get it in, so I just closed it.
So Blackboard's kicking you out, or
Yeah, I can get to Blackboard. I can get to our class,
And then if you click on specific things,
but I mean, this is. At first, it wouldn't even load up my
Assignments.
it wouldn't even load up my
This one?
And I got to there and
I
it
did
turned a blank
these,
screen.
but I didn't use half the formulas.
Oh,
here. Yeah, I just did what I added those from the charts that we watched for the videos. I had to because that's
Okay, so like I don't know if now I will tell you I don't know if this formula builder is just in the Apple version and not in the Windows version or what, but see, this will tell you, this tells me that if I highlight var.p, it calculates the variance based on the entire population. Okay, and it tells you what that looks like, var.p, and then you have to put in the numbers. S estimates variance based on a sample. There's another one, estimates variance based on a sample, including logical values and text. And that would be one where, let's say, instead of your scores being numerical, they were F and T for true and false according to this. You can do that same kind of process, same kind of deal with the population. Now there are some differences if you're running an earlier version of Excel, but in this case I'm going to use var.p.
Oh, I see.
And it allows me to, the way I'm going to do this is it allows me to put the numbers in, I know, leave me alone, equals var.p, and I'm going to use the variance between here. I wonder if it's going to let me do every one of them. Yeah, it will. No, don't put a plus in there. There we go.
Okay.
B 290. What do we say? 291.
Yeah. Yeah. Here. Do you want me to email you this after we get done with class so that you also have a copy?
Do we all know kind of where we're at and what we're doing?
On a meeting, did you have to line them up first, or did you just put it in the raw set?
Nope. I just put in the raw. It just
It does it for you.
median, and then just give it the range of cells. B whatever to B whatever. Make sure you're separating them by a colon. You have to separate them by a colon. And then standard deviation is I didn't want standard S. I want P. Through 291. Okay, so my mean is 230.5. My standard deviation looks like it's 20. Does that make sense to everybody?
Can you show me how you did that again?
The standard deviation?
Yeah.
It's just,
Same basic B. Okay.
yes.
Thank you.
Nina, what are you thinking?
I thought the standard deviation was the square root of variance.
When I did that.
It is.
Did I use population? Yeah, I used population on both. So,
Oh.
Isn't
but
the-
your formula? It automatically does. It does. You don't have to put in
no, it doesn't.
square
form-
root of
Right, no, that's why I'm
of
using.
G whatever.
That's
You
right, that's
actually
why I'm
use
using it.
Excel to calculate.
You tell Excel what you want it to do, standard
I'm a
deviation.
little behind.
That's okay.
I understand now because I had all the other stuff in my head.
Right.
I got all the other formulas, so I could have done square root of G7, and it would be
Yeah.
same thing.
Okay. Z score. Raw minus mean
Okay.
I did. I'm up there. This law minus mean divided by standard deviation.
I literally had never worked in Excel at all, ever, until that first assignment.
See, that's hard for me. I'll just be honest with you. That's hard for me to comprehend.
No, I'll do anything to not have to do that, or I would have, not anymore. But I never had worked in Excel to know how to use any of it.
Right.
And so that first one was.
Well, you are more than welcome to calculate it all by hand if you'd like to.
My husband's a CPA though.
Okay, well, there you go.
After I spent an hour and a half of my own figuring and going, there were just a couple things that I couldn't get. And so then he sat down and talked me through the rest
There you go.
to do it. But I wanted to try to work it and do it myself. So I still don't have it.
But you're getting there.
But I'm getting there.
Okay.
But I've never, like, I'm telling you, I have never worked in
I
Excel.
want to see if this works.
Okay, so
We gonna figure it out later.
on my Z
So let me
score,
try.
I take my raw score. Let's do B2 there. It's B2 minus where my mean's located, but I put a dollar sign in there so it doesn't change.
Uh-huh.
That's in parentheses divided by standard deviation.
Yes.
And now all I got to do is highlight the little box, put my plus sign, drag it all the way down, and it'll do all of them.
Yes.
That's the theory.
What is the keyword for T-score? Like standardizing T-score, right?
Yes. So let's do that real quick. All right, so
I don't know if I did it right.
I'm going to, now, I'm going to do it from here, just so insert function.
Ours walked us through. It's nice.
Standardize. Okay, so what this does is it standardize is going to return a normalized value by a mean and standard deviation. Okay, so what that means is if I type in standardize, I tell it what the x is. So the x is over here. I tell it what the mean is. The mean is over here. Ooh, wait. Tab. Oh, cut it out. Mean is here, and the standard deviation is here, and I hit return.
Okay, wait a second. Okay,
We did it the hard way.
That's okay.
I'm going to insert
Like numbers in.
That's okay. That's okay, because you can do that, right? And I should get the same thing. Did you get that number? Okay.
Okay,
So-
do it one more time.
Okay, so I did this way. I'm not sure if yours will allow you to do that. Okay, you should be able to just do equals, standardize.
Yeah.
Okay, now do you see, does it give you that little yellow bar that says X means standard deviation?
So you
No,
got to
it
tell it
just
where all
says
those values are.
standardized.
Okay, so then the next thing you'll just have to remember then that the next number you have to put in is the X value. Well, X value is, for me, B2. And I just click on it. You could type it in, but I just click on the B2.
I messed everything up.
It tells me what to put in, but I can't click on anything.
I don't know how to fix what I did.
Just click right there on 234.
No, it doesn't want to let me anymore.
Oh,
Now,
Don't
you have
know.
to separate them. See, it shows you have to separate them by commas.
Oh, that's just wicked.
and then do I just click on?
Standard mean.
I just click on it.
Uh-huh.
Gonna put it through my computer
Comma.
against the wall now.
Standard deviation.
Oh, and I
You haven't
haven't
figured
done
your
that
standard deviation yet.
Okay.
Now you can click on the cell. Go ahead and click on the cell. Now hit return, and you're going to get an error. Go ahead. Now, as soon as you figure standard deviation, that z-score will fill in.
Oh, automatically there.
Yeah.
Okay.
Okay. Now,
Oh, wickedness.
let me show you something. Okay.
My computer went down on me. I got the standardized score, and then I tried to drag it down, and now I've got that, and it messed up the standardized score.
Okay, so you're going to have to redo the standardized score
And
formula. Okay, now here's when you're going to drag this down, because you can just drag this down. Okay? But I want to show you if you do without doing a couple of things, you're going to see you get some errors real quick. All right, because let's look at what it did. It went from what I told it, B2, G4, and G8, to B3, G5, and G9. Well, G5 is the median, and G8 is nothing. Well, so that it's not telling us, it's not giving me or doing the mean and the standard deviation anymore. That's because when I drag it down, what you're doing is you're telling Excel to take whatever's in here and come down one row. Take whatever's in here and come down 2 rows. So it's going to come down here, which is good, but it's also going to come down over here, and it's going to use non-numbers. Yeah, you all can leave whenever.
Sorry, I've got to pick my son
That's
up.
fine. Go. Go.
Adrian has promised to text me the next secret.
So what I'm going to do is I want it to go ahead and change B2. That's fine. I don't want it to always pull from B2. I want it to pull from B3 and B4 and B5 and B6 and so on. But I do not want it to move from G4 and G8. It's got to stay on G4 and G8 because that's where we're pulling the mean and the standard deviation. And so what I do is I go in and I tell Excel to stay on G4 and G8. And the way I do that is I add a $sign. And I add a $sign.
So a $sign makes it stay.
Oof. A $sign makes it stay.
If I do this
G8.
8.
A $sign makes it stay on whatever you put the $sign on. So it'll stay on 4 and 8. And as long as I drag it down, it'll stay in column G. But the minute, let me show you something. The minute that I pull it over here, notice it changed from G4 to H4. If I wanted it to stay G as well, then I'd put a $sign in front of the G. Now, why don't I have to do that? Because I'm not pulling it side to side. I'm only pulling it up and down. And as long as I only pull it up and down, I only have to worry about the number. If I pull it side to side, I have to worry about the letter. But I'm only pulling it side to side, so I don't need to worry about the other. Okay? So now, when I pull it down through here, I'm just dragging it down, and it's all going to stay the same, and it's going to give me values. Now I'm going to format the cells because I only like the numbers to be no more than 2 decimal places. And you'll notice I have some negatives and some positives. So now I have an idea of where those fall. Now for the t-score, I just have to put in the formula. So the formula for that is just the numerical formula that we saw. And it's this times 10 plus 50. Same thing, I pull it down. I convert that to a number with no more than 2 decimal points. And you'll notice they're all positive. Even the negative numbers have turned to positives.
Sure is a lot easier than writing your own formulas. So I can go back and do my Z-scores on my test. Data. Then it's gonna tell me a lot about those 12 kids.
Okay.
I didn't get mine copied down. I'll get you some.
It's to play with yourself.
If you're not right on that corner, and that plus sign doesn't change to solid.
Yeah, it's got to see it's white, black.
Oh, okay.
Yeah, it's gotta be black.
They weren't perfect last time.
That's cool. So this was our midterm. Please. Pretty please.
Afraid not.
Oh, I need to send this to you, don't I?
I'm sure.
Okay, everybody good? I'm gonna unplug here.
It kind of freaks you out when one thing goes wrong because you don't know how to fix it, and you're just like, everything's wrong. Everything's wrong.
That's about all of that.
So are we done for the night?
Yep. We are 10 minutes longer than we should have been.
I'm gonna go ahead and quickly email you all the work that the literature review, everything that I got.
Okay.
Right, so I'm just gonna get, because when